All right, so this is chapter 25 quiz, okay? So first one, a vertical polarized beam of light intensity passes through two ideal polarizer, okay? So you have, this is polarized, right? So you have two polarizer, right? So this is 100 watt meter square, all right? So this is central axis, right? So the first one is this, right? Polarizer. This is the 20 degree. 20 degree, right? Okay, 20. Let me see, that's 20 degree, right? The second one will be this. So this is the 40. Okay. Suppose it was vertical. What is the intensity of the light after it has passes through both? All right. So from law of Malus, we know. So this is I naught, I1, I2, right? So when you pass through a polarizer, if this is a polarized light, right? So I1 equal to I naught cosine theta square, right? So whatever angle between polarizer and the direction of the polarized light, okay, beam, all right. And so here I1 equal to 100 cosine 20 degree, right? So what's the I2? Okay, so I1 then passing through this one. Well, here the angle between between this polarizer and that polarizer will be 20, because this one is 20 was vertical, 40 was vertical. Okay, so the angle between this guy and this guy be 20. 40 minus 20 is 20. Okay, so I2 equal to I1 cosine. Okay, so this is a 40 minus 20 squared. All right, so this is I1 cosine 20 squared, right? Okay, so I1 is this, right? So for this question, I2 equal to 100 cosine 20 squared. Then you get this is I1, right? Then you have another squared. Okay, so that's a good answer. All right. Second one. Second one, the maximum value of an electric field. Okay, so this is E max. Okay. In an electromagnetic wave is this, right? So E max equal to 2.0 V meter. All right. What is the maximum value of the magnetic field? Well, this is very simple, right? So magnetic field maximum equal to E maximum over C. Okay, we know E equal to C times B at any given moment, right? Okay, so this is pretty straightforward. Let's just plug in. Okay, number 3. What is the wavelength used by radio station that broadcasts at a frequency? This is a frequency, right? Okay, wavelength, very simple, equals speed over frequency, right? Speed is 3.00 times 10 to the power 8, right? Frequency 920 kilohertz, right? K3, right? It's a kilohertz. Well, that's a wavelength, okay? Actually, it's pretty long wavelength, right? So whatever value it is, you can just plug into this equation. All right, number 4. In an electromagnetic wave in free space, the electric field and magnetic field are, okay, we know they're perpendicular to each other, right? So E perpendicular B. Okay, so in class we talk about if this is E, this will be the B. Okay, they're perpendicular. All right, so let's say parallel to the one another. Okay, now parallel to one, perpendicular to one another, and perpendicular to the direction of the wave propagation. Okay, so yes, they perpendicular to each other, and both of them, well, basically V perpendicular to the plane formed by E and B. So E and B form a plane, speed of wave perpendicular to that plane. All right. So looks like a 2 is good, perpendicular to one another and parallel. Okay, long, parallel to one another, and okay, so all right, so number 2 is right. So basically, E perpendicular to B, E and B both perpendicular to speed of wave direction. Okay, so this is a V, right? E is this direction, B is this direction. Okay, all right. Number 5. A sinusoidal electromagnetic wave has a sinusoid, okay, so that's important. Has a peak electric field, okay, so we know E peak, right, equal to 8 kilovolts meter, okay, so what do you do here, this, remember it's a kilovolts, right? What is the intensity of the wave? Intensity, right? Okay, so what's intensity? We know that intensity, let's make a little bit derivation, right? So intensity basically is, we know it's about the energy, right? Over time, over area, right? What's energy? Energy is energy density times volume. Okay, in class we talk about volume is a CTA, right? Okay, so we have a beam, right? So this length is CT, this is A. Intensity is intensity, right? This is area, right? This is volume, right? Divided by TA, right? You see TA cancel. So this intensity is UC, all right? So now what is the intensity, right? So what intensity? Okay, so here is, this is intensity in general tells you about the root mean square value of the so basically it's a kind of average intensity, right? This is your instant energy density. Okay, so you care about is root mean square value, right? So we know U equal to instant intensity equal to 1/2 epsilon naught E square plus 1/2 B square over mu naught, right? Also, this equal to, because this one equal to that one, so epsilon naught E square. Okay, so we have to look at root mean square. So we put the root mean square value of this guy to figure out. So you look at average intensity, right, equal to U average C, right? So what's the U average? You use root mean square, epsilon naught E root mean square C. What is root mean square? Epsilon naught E max divided by square root 2 square C. All right, so everything is in place. Okay, so what's the intensity? So equal to epsilon naught 8.85 times 10 to the negative 12. All right, so this is peak value, right? So 8. Let's do this. Let's make this 10 to the power of 3 volts, right? Divided by square root 2 square, then times C, 3 times 10 to the power of 8. All right. So whatever it is, and then they go back to kilowatts, right? So whatever get here, now you make it kilowatts. Okay. All right. So kilowatts, right? So now whatever here is watt per meter square, and then you turn to kilowatt. All right. Okay. Next one. A light source radiates 60.0 watts of a single wavelength sinusoidal light uniformly in all directions. Okay, so basically point source, right? And we know power equal to 60.0 watts, okay, in all direction. What is the amplitude of the electric field of this light at a distance of 0.4? All right, so 0.400 meters. So here, this location, ask you about the amplitude of electric field. Okay, so how to figure this out? First, we know intensity, right? So intensity at this location. So you see, this is a point source, and then emit a light in all directions. So whatever power will be shared by the whole spherical surface, right? So intensity at this location equal to power over 4 pi r squared. R equal to 0.4 meter, right? And okay, so from previous question, right? So this intensity you get is average intensity. Okay, all right. So let me see. You see, use this equation. Use basically this equation, right? Okay. So in average intensity, right? So equal to epsilon naught amplitude, right? Amplitude square root 2 square times c. You see everything is in place, right? So this is 60.0 watt. This is 0.4 meter, right? This one, you know this one, and you know c, right? So everything is given except looking for this guy. All right. Looking for amplitude, okay, amplitude of electric field, okay? So if you're looking for amplitude of magnetic field, then you have to use this guy, mu naught, right? Okay. Number 7. How much energy is transmitted across this is area, right? Per hour by a sinusoidal electromagnetic wave. How much energy is transmitted, okay? Whose electric field has a maximum strength of this. So this is maximum strength. All right. Talk about energy, right? Okay, you see, they gave you how much energy is transmitted across this area, right? So this is area. Energy equal to intensity times area, right? Okay, and then times time an hour. Okay, there you go. Everything's in place, right? So what's the intensity? Intensity, if you know the maximum strength of electric field, right? Okay, basically we talk about same equation, right? So intensity here is this. You see, epsilon naught E maximum divided by square root 2 square C. That's intensity. And then you talk about area, right? 1.0 centimeter square, right? Centimeter square equal to okay, so 10 to the power of negative 4 meter square, right? So 1 meter equal to 100 centimeter. 1 meter square equal to 10 to the power 4 centimeter square, right? So 1 centimeter equal to 10 to the power negative 4 meter square. And what else? Time, 1 hour per hour, right? So hour will be 3600 seconds, all right? So here you have 30.4 here, square root 2, okay? Yeah, we can also simplify this way, right? So epsilon naught is given, right? E amplitude squared divided by 2, right? C, and then A and T, all right? So that'd be energy. Okay, number 8, okay? All right? Unpolarized light passing through an unpolarized, okay? Passing through a combination of two ideal polarizer. The transmitted axis of the first polarizer and the second polarizer are at 30 degrees to each other. All right, so first, this is unpolarized. Okay, in all direction, right? So polarizer, another polarizer, right? Okay, so those two, 30 degree. Okay, so basically that's the idea, right? So this is I naught. Path the first one will be half I naught. Okay, then path the second one is whatever here, half I naught, right? Then cosine 30 to each other, 30 squared. That's it, right? Okay, so what percentage of the original light get through the combination? Well, basically this is your passing through, right? So initially it's I naught, so ratio, right? So ratio will be 1/2 I naught cosine 30 squared divided by I naught percentage, right? So this is a half. Cosine 30 will be square root of 3 over 2, square it, right? So it's a half, 3, 4, 3 over 8. Okay, 3 over 8 will be what? Well, this is answer, yeah. 3 over 8 is 0.375, right? 37.5%, all right? Next one. Which one of the following is not an electromagnetic wave? Not, right? Infrared, yes. Gamma ray, definitely yes. Sound wave is not. Radio wave, yes. Ultraviolet, yeah. Okay, all right. Number 10. An electromagnetic wave is propagated towards the wave west in the free space. West, right? Okay, so let's see. What do we do? West in the free space. Assume this is west, right? Okay. Wave propagate. Okay, so this is speed of wave direction, right? At a certain moment the direction of the magnetic field vector associated with this wave point vertically upwards. At this moment, right? Magnetic. What is the direction of electric field? Okay, so we know, use your right hand. Electric field, current magnetic field, right? Okay, and electric field also perpendicular magnetic field. So this is up. Electric field will be coming out of screen, right? So this is electric field. So you see, use your right hand, electric field, and then curl to magnetic field, and then thumb give you direction of the wave, right? So vertical and point upwards, no. Horizontal and point south. All right, so this let me see. Okay, so this is west. Okay, so this is west. Point to the west, right? Okay, so assume point to your left side, right? So will be upper is vertical will be your so it will be horizontal, right? So this is horizontal. And point south. Yeah. So okay, this one, right? So make it horizontal and south, right? Point towards you will be south. All right. So I think B will be. Yeah, B is right. Horizontal and the point east. Okay, that doesn't matter. This is not because the east and the west is parallel, right? So E perpendicular to V. B perpendicular to V. E perpendicular to B. Okay, so that's a relationship. So C definitely is not right. So this is not right. Vertical and pointing down. Okay, no. If pointing down, then it's in the same direction. It's in the parallel to the B. Wrong. Horizontal and point to the north. Horizontal point to the south, north. Okay, so if left is west, right? So assume let's point west. Then point towards you will be south. Yeah, I think this is right. Okay, so last one will be like this, right? Okay, so this is not a right-hand rule, right? Okay, so number 11, a radio transmitter is operating at an average power of this, right? So power, and is radiated uniformly in all direction. What is average intensity of the signal this much kilometer from the transmitter? All right. Okay, so let's see. This is power, right? Power is 4.00 kilowatt in all directions. What is average intensity? So intensity, okay. So the intensity meaning is P over area, right? Power over area. P over area is in all direction, right? So 4 pi r squared, right? So equal to 4.00 kilowatt, 4 pi 8. Well, let's make 3 square and then make this is 10 to the power 3. All right. This will be the answer. 4. So 10 to the power 3 pi 64 6, right? So it's a 3, negative 3. So pi will be 3. Well, just well, it's very small anyway. Just use a calculator. I guess it would be in the micron. So this one is 1, 2, 3 milli. Well, definitely less than milliwatts per meter square. It will be in the micron part. Okay, let's see. Okay, anyway, use your calculator, figure this out.